Draw and name the 3D solid of revolution formed by revolving the given 2D shape about the indicated axis. And we have ourselves a vertical, and by vertical I mean horizontal, axis of revolution, and what is its volume. So we saw something like this in the warm-up activity here, that when I revolve this thing around, it's going to make something that looks like a roll of tissue paper, a roll of toilet paper, something like that, which we call a washer. So here's what it looks like. And the general technique to find the volume of that thing is find the volume of the larger disk and then subtract out the smaller disk from it. So it'll look like this. So the larger radius is the one from this horizontal axis all the way to the top of that rectangle, whatever that function might be, and then multiplied times our little width that was there, and then subtract out the smaller one, right? So it's just pi r squared times the height, pi r squared times the height. Now we're going to do a little bit of fancy factoring here. We're going to pull this pi out because it's a common factor of pi, and there's also a common factor of that width of that rectangle. So we'll pull them out on opposite sides, and you'll see why in just a little bit. So the big R, of course, is our outer radius, and the little r there is going to be our inner radius. So we're going to apply that to some sort of function, functions that are in the coordinate plane graph, sort of like this. So let's say that I wanted to take this plane region and revolve it around this horizontal axis of revolution. So can you visualize what the heck that thing is going to look like? And then you can see that all of this white space here is going to create some sort of hole. It should look sort of like this. It looks like maybe a lampshade, or like think of Doug in Up, that little dog collar kind of thing. That's sort of what it looks like, right? And it's hollow. It's hollow on the inside, so we have to subtract out some of that thing. So if I wanted to find the volume, again, I would start with that representative rectangle, rotate that thing around, and it's going to generate a disk, a washer, I should say, that we would find the volume, just like we found before, where delta x, of course, is the width. I'll come back over here. It's the width of this rectangle, and then we have, as far as our two radius, our upper function, and then our lower function that's right there, right, as our two radii. And then that's just the area or the volume of one of them. I want to find the volume of n of these things, which will take on the shape of a Riemann sum. It's a Riemann sum because this is two functions that are being squared and then subtracted. Well, that in itself is also a function multiplied times a width here, which is a Riemann sum. And by definition, if I take the limit as n approaches infinity, once again, that will turn into a definite integral, right? So here is that limit of the Riemann sum, turns into the definite integral from a to b, pi times, and you can see it's the outer radius squared minus the inner radius squared with respect to x. And then I might clean this thing up just a little bit by taking that pi on the outside of this whole entire thing. I mean, if you wanted to. There is, once again, our outer radius function that's being squared, and then our inner radius being squared. And we will apply this washer method in the next couple of videos.